So hey everyone, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and WallArm. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting webinar ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded. So if you miss any of our conversation, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in using the Q&A tab, which you'll find on the right side of the screen. This is also where you'll find the chat tab, and that's where we want you to engage with your fellow audience members. Let us know your thoughts throughout today's program. And I will also point your attention to the Handouts tab. Here you'll find a copy of today's slides. Feel free to download those at your own leisure. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is the 2022 Guide to API Security. And joining me is Stefan Ilian, co-founder of WallArm, and Alex Diaz, Vice President of Security Solutions at WallArm. Alex, Stefan, thank you both so much for being here with me. I'm going to let you take it from here.
Thanks for having us.
Thank you for having us, Cody.
Yeah. It'll be good to start, right?
That's right.
Okay, so we're talking about the API security in 2022. We want to make this talk very practical. So to give you some practical insights, tips, our tools are something that you can try out right away. And there are a lot of things that are kind of low-hanging fruits. A lot of things are hard to implement, but what we wanted to do is just to give you something where you can start, or maybe you can start some directions for the API security. Let me give you some kind of points that we've been talking on today. I'll start with the kind of retrospective of what were the API security issues over the last 10 years. It's actually more, like over the last 22 years. We did a great research on that, so I'll give you some insights. We'll talk about the API security checklist, this kind of the practical checklist that can help you and guide you through the different areas of the API security so that you can start using different kind of stuff and like have some kind of guidance, like what to do and what can be helpful along the way there. We'll talk about the layers of the API security, basically the tooling that you can start using today. And what I want you here to understand, like what is enough when, right? Like when some kind of API gateway can solve some of the issues, when you need some kind of more robust tools and etc. So like we'll talk about these layers of the API security. And the last one is team training. So like how to make sure your developers, your DevOps guys, pretty much everybody in the company understands what are the issues with the API security and what is the best way to train them on this topic, because that's not easy, and to make sure that the developers even think about that thing is not always a easy thing to do. So like I'll talk about that. And we'll also talk about the WallArm, like the company that we are presenting, and how it can help you in addition to what we've discussed like in the first part of the presentation. So let me start with some kind of data. Not everybody knows, but 83% of all the web traffic are API calls. Like, can you imagine, like 83% of all the web traffic are API calls? Like it's majority of everything. And it's like what Gartner is saying, like some people believe Gartner, some people not, like, but it's, what are they saying? It's 90% of all the applications would have more surface area for attack in the form of exposed APIs, which is a really, really big thing. When we've been thinking about the API security, the idea we got is that, hey, yes, API security is hot. Yeah, like everybody's talking about the API security now, but in reality, it's all about APIs for quite a while, right? And even 10 years ago, we knew that there were APIs, we knew that there were some kind of vulnerabilities. So what are the trends? Like, is there anything changing really? So what we did, we took the data from the publicly available CVEs. Like basically we analyzed 10,000 CVEs. We also took data from the bug bounty reports and different kind of like exploit definitions where APIs are mentioned directly and indirectly. And initially we wanted to do it like for 10 years, kind of cool number, right? 10-year retrospective. But in reality, we actually did it for 22 years, like even more. And what we discovered, we presented in the special talk, we call it API Security 10-year retrospective. You can find it on YouTube. But I'll give you a few insights from that report. So like number one thing is API exploits are growing exponentially since 2015. So like we just see more and more vulnerabilities and available exploits. And like on average, it's 5 exploits a day. It's like, can you imagine? I just like, just look at the graph on the right side and you would be surprised. So our API exploits are a very common thing for a while. So this is the graph goes back to the 2006, and you can see that the number of the API exploits are basically like every day we have more and more vulnerabilities. Every day we have new exploits, and we just know that once the exploit is published, like it is exploited all over the place, especially if the CVEs score is high. Another thing is about the APIs and the type of the APIs. Like majority of the API security covers web APIs. When we talk about the REST, GraphQL, gRPC, something related to the WebSockets, but there are like also APIs that are kind of binary APIs, database APIs, and like you can see on the right side what is the split between all of them. So I would say the majority of the APIs, when we talk about the vulnerable APIs, are still web APIs. And the third insight is that CVEs score is actually not changing much. So like we see that this is, and by the way, on the right side, 0 means no exploits available. So like what you can see is just like API security is a high risk for a while. So like it's like roughly it's 6.0, and like you see, it's a fluctuation. So it is there. We also publish API vulnerability report. It's kind of a quarterly thing. You can just go to the wallarm.com and download it for every quarter. We try and analyze like everything we can find are publicly available and sometimes not publicly available about the API vulnerabilities, and give you this kind of like summary of what happened over the last quarter. It's kind of like cool infographic. What's interesting, I really like this infographic here. So on the left side, we show what we call OWASP heat map. So it's basically, you can see like how many vulnerabilities of every OWASP top 10 and every OWASP API security top 10 like we managed to find, and they can see like what is the most common thing. So like on the left side, you see like the most common thing is injection and broken access control. On the right side, it's OWASP API security top 10. It's just like injection is the #1 thing. So it's kind of cool because you can see like what is the trending thing, like where the vulnerabilities and the critical vulnerabilities are occurring every day. And on the right side, like we also try to kind of connect this OWASP top 10 API and OWASP top 10 because like when we talk about the security, like and the web security, we always refer to this OWASP top 10, right? Now with this API security scene, we also talk about the OWASP API security top 10. In reality, they overlap a lot. So like we try to show you where is this overlapping happening and where you need to look through. So like highly recommend to download it and just basically to explore it. Some of the people are asking us, what are the types of cybersecurity incidents that are related to the APIs? So let's talk about them on the example of the fintech company. So like, first of all, it's obviously data exfiltration. So like if there is a vulnerable API, you can exploit it and you can basically get sensitive data of customers, like, or some kind of other PII data. So this is the #1 thing. Another thing is like fraudulent transaction. So like this is specifically important for the APIs. If there is some kind of business logic issue, the attacker can probably, like in many cases, it is possible to exploit it and to perform fraudulent transaction. Or another thing like service disruption. Like when API is not protected, you can abuse it, and you can make sure that like the app is not working the way it's supposed to work, and like you can execute different kind of denial of service attacks, or even the business logic attack that can lead to the service disruption. And the last one is the account takeover. So basically, credential stuffing, brute force attacks, and et cetera, and et cetera. Like it's so much easier to execute this kind of attacks against the APIs, and we'll talk more about that. I will give you like a few challenges here, and we'll talk about like what you can do with these challenges. So let's start with the first one. API and application usage has exploded. So it's basically APIs are everywhere. When we talk about the APIs, we basically talk about three types of APIs. Private APIs, like only used within your company, and it's usually microservices, right? They are internal, sometimes they are exposed, sometimes they are not exposed. And those APIs are private. And like majority of them are, this is by the way, the data from the Postman 2021 State of API report. So majority of the APIs are private. They are not exposed. And like some people think that they are protected because of it, but like in reality is that like the good practice nowadays is to make sure that you are protecting even those APIs that are internal. But obviously there are also public APIs and partner APIs. Partner APIs, this is a very specific thing, but for some industries like fintech or e-commerce, this is very important because you talk a lot with the partners, and like all this communication is usually happening over the partner APIs. And why it's important to think about them in terms of the security is because sometimes you rely on some kind of third-party API and you trust them. You get some kind of data, you don't sanitize it, you like kind of trust it blindly, which is obviously not the most secure way to do it. So like when you're getting anything out of the partner APIs, make sure that you're analyzing the data that they're getting out of it. Speaking about all of those APIs and the number of APIs, the challenge a lot of companies have is that it's not clear, like, what are the APIs we have? Like, what are the endpoints? What are the versions of those APIs are exposed? And like it's hundreds, sometimes thousands of APIs and endpoints. Some of them are managed and you control and manage them with the API gateway. Some of them are not managed, and like some kind of developer just spins up our API endpoint just to make it exposed, like available to the whole world. And nobody in the company even know that it is exposed. And just a reminder, this API can expose like any kind of sensitive data, right? So when we talk with the companies and we ask, how many APIs do you think are exposed? Do you think a lot of companies know the answer? Not really. So like, regardless of what the company is saying, we can run this inventory and discovery exercise. And like in most cases, I would say like the majority of the cases, people don't really realize like how many endpoints are available. And there are a lot of surprises. So there can be some zombie APIs, some legacy APIs, some shadow APIs, some of the very common thing is that there is some kind of API, let's say it's authentication API, and for years it was V2 version, but then like the company switched to the next version, like V3, but they decided to keep this V2 for some time for compatibility reasons, and like apparently like all the time, everybody just forgets that there were like two versions of the APIs, and meanwhile both of them are available. The question, like, do you keep updating your V2 API? Do you keep fixing all the bugs and vulnerabilities or not? So there are a lot of things there. And the interesting data about the managed and unmanaged APIs that like by 2025, like it is expected, but that the half of the APIs wouldn't be managed. So like they wouldn't be a part of your API gateway like home or etc. So like it's crucially important just like to know what is actually out there, because like every API endpoint can expose sensitive data. For that, you need to have some kind of discovery tools. Luckily, we have some open source things that we can use. So I always refer to this API Clarity, which is the open source solution. It works in Kubernetes, and it actually can discover APIs and track changes. So it has a lot of limitations, and it works only in Kubernetes, but this is a good start. You can get a picture what APIs you have based on the actual traffic. And they obviously, like as a company that works in the API security space, like we invest a lot in the API security use case as well. We'll talk that during the demo, but based on your traffic, we can basically have a list of all the API endpoints you have and track changes, identify shadow and zombie APIs, identify where the PII data is exposed, where the sensitive data goes in and out, and that kind of stuff. We'll show it during the demo. Let's get back to the challenges. So the next challenge is that the velocity of innovation is high, and what is also a challenge is that the complexity of API increase very in a very serious way. So what do we know and what do we see? Like all the companies try to keep up, right? The competition is it's not a joke. Like you need to keep up. You need to have the velocity at a very high level, and it brings more security issues because like when you release more code, when you have more changes, you inevitably introduce more security issues. And like the plans for product and dev teams are getting more and more aggressive. So like we know this like based on our own company. And what makes things even worse is that the stack is changing. So like nowadays, like what we need to deal is like REST APIs, GraphQL APIs, gRPC APIs. Everything is organized in Kubernetes clusters. People start using service meshes, and as a result of it, it's getting hard. Like protecting all those things are not an easy thing to do. Like we have less best practices. Those things are less explored. And a lot of tooling is not ready as well. All those new tech also introduces blind spots in testing coverage, in protecting, and et cetera, and et cetera. Just to give you an example, a lot of people rely on WAFs, web application firewalls, to protect their web assets. But in reality, a lot of WAFs are not ready to protect APIs. You would be surprised. Some of the key vendors, they can't even properly parse the JSON. And that's the thing that you need to deal with. So when you introduce something like GraphQL or anything else, just to make sure that something that you already have and trust can actually be effective in protecting assets that you have. Same on the testing side. A lot of tools are not ready for the API stack. They are not ready to test APIs. Like if you have Dest, it's not that easy to crawl the APIs. You can't do that, right? So you need another methods to scan and test APIs. You also need to think about the state, because it doesn't make sense to test the checkout API before you add something to the cart, and etc. So when people are asking us what we can add into the CI/CD pipelines to test APIs, we give a list of the tools. So these are a few that are pretty helpful. So I will definitely recommend to use Zap. So it's kind of OWASP-driven project. There are some limitations like no gRPC support, but it can be a good start. There's also Wrestler and Dread. Those are the OpenAPI Swagger-based fuzzers. So it's basically you upload the schema and they can fuzz different kind of API endpoints. The Wrestler comes as a project from the Microsoft research. So it's actually pretty good, and I'll recommend to try it. Schema Thesis is a similar project to Wrestler and Dread, but it has the GraphQL support, which is getting more and more important. I also recommend to use AB or JMeter. This is the way how you can introduce the performance testing and basically create some volume of requests coming to the specific API endpoints and test them if they are ready to handle all those things. And there's also the tool which is called Go Test WAF. And don't be fooled by this WAF word in the title. It's actually a tool developed by Wallarm team to test different kind of GraphQL, WebSockets, REST API endpoints, and to give a score of how this API is really protected against different kind of threats. So this is open source project, just try it out and see how your assets are protected. Now, tools are good, and I'm happy to give you this list, but in reality, having tools is not helping you when you're not really understanding the risks. And obviously in this webinar, we can talk and go through all the risks related to the APIs, right? It's just not possible, unfortunately. But what we try to do and to give to our customers as the foundation, as the guiding principles for their API security programs, we came up with the document which we call the API security checklist. So this is a practical guide, like it is written specifically for the security teams and engineers, and it has a lot of data and practical steps in a form of checklist. So no surprise, right? That can help you to start your API security, and we have like a few sections there. So that's just to give you an example. So like the first section is the risk of improper API security management and discovery. And we discussed with you that having the inventory of APIs and running the API discovery is very important. So like this is just like a recommendation of what you can do, right? So like the recommendation is like having an API inventory of all API infrastructure, then continuously run the API discovery to identify changes in the attack surface and shadow and log APIs, and et cetera, and et cetera. So like this is what you can do, but you also can use the tools that we are recommending. So like we already mentioned this API clarity or the wall arm and et cetera. So like this whole manual is the list of different kind of risks and very specific things that you need to do. Like this one, API abuse and lack of resource and rate limiting. So like on the right side, you see all the recommendations you can start using. So like the first one obviously is that you need to introduce the rate limits for every API endpoint that will limit how many requests client can make in a given period of time. Like it's that simple, but like it's those things that you're going through and like you have a checklist, done. Like I'm now pretty sure that I'm protected against API abuse. And by the way, like in many cases, you don't really need any commercial tooling for that, frankly. Like you can do a lot of stuff with the existing tooling, like this rate limiting. You can use like load balancer, like Nginx or Envoy, or like open source API gateways like Kong or Tyke. So like on the right side, this is just an example of the Nginx configuration when you actually create the rate limiting by limiting the by introducing 10 requests per second limit to the login endpoint. So like it's that easy. Obviously, we talk about other stuff like injections, right? Like this is still one of the most critical issues for the APIs, which can lead to the data breaches and etc. So like we give you what you can try and use, and we once again like we give some recommendations on the tooling. Another tooling from WallArm, it's completely open source, by the way, free of charge, and feel free to contribute it. It's the open source API firewall that does the API schema validation. So it's what's usually called a positive security model. So what it can do, it will operate as a reverse proxy, and it will allow calls that match a predefined API specification. So basically upload the specs like Swagger, and it will enforce it. So like everything else will be rejected, and the only calls that are matching a predefined API specification will hit the protected app. Surprise, a lot of commercial vendors, like WAF vendors, they actually sell this API security feature, and like the only thing they can do is this positive security model. So like they sell it. In reality, you can just take it. It is deployed as a Docker container or some other forms that can be suitable for you. You can just like use it for your exposed APIs, for your internal APIs. So like this very simple concept, it shouldn't be sold. It's just like everybody can and should have it free of charge. So that's why we open sourced it. So welcome to community, contribute, because like this project has a lot of potential, and we will be happy if you will help us like to work on it. There are some other parts on the API security checklist, like we probably wouldn't have time to talk all of them, but it's broken user authentication. On the right side, you see what you can do to protect your APIs. But obviously, one of the most important things is just like using some standards, not introducing anything new. Like you really need to use them, like OAuth or GWT or etc. Another thing is like insufficient login and monitoring. So unfortunately, when we speak about the APIs, it's a very like even if you have logs for the web server, in many cases you don't have enough visibility. Most of the requests are coming as a post, and you don't see all the parameters and etc. So like you really need to have some kind of tooling in place that can provide visibility of what was happening, where the attacks came from, what were inside those attacks, what were the API endpoints that were affected, were those attacks are really dangerous, are really exposing any vulnerabilities, and etc. and etc. So like there are a lot of things you can do there, but this is another chapter of the API security checklist. Once again, you can download it from the wallarm.com. I tried, and I think I managed to do so. I created a link here in the webinar software so that you can just go to the website and download it right away. I'll skip these other parts and switch to the next question. Like, okay, we have this API security checklist, right? So, and we kind of know what we need to do. We have this all recommendations of the tooling, and vendors of the API security are attacking us from all over the place by saying that they can solve our issues on the API security. But unless you actually have something that is helping you to train the team, like it wouldn't be possible to introduce all those changes. So what I usually recommend when people are asking about like how to train the team about the API security, and by team I mean both engineering teams and security teams. So like I think the good thing is to have intentionally vulnerable API, some kind of like sandbox where you can play around, when you can get familiar with the traditional web security vulnerabilities, where you can get familiar with the API security related issues. So we're lucky to have a few projects like that. So like this is a list of those, like CR API, which comes with a set of the challenges. So it's basically not all. Yeah.
So your screen share actually isn't working at the moment. Go ahead and try that one more time for me.
You can see it now, right?
Yes.
We can.
Okay.
Feel free to continue.
That's good. Yeah. Thanks, guys, for heads up. So I was talking about the sandbox, like how you can train the team. And one of the best things you can do is to have some kind of interactive training. We'll talk about that. But what you need for the training is basically some kind of intentionally vulnerable API. So like we have a few options here. So like CR API, it's the project from the OWASP. It has challenges, deployed as a Docker container, very easy to start. VAPI also comes with a different kind of exercises. It also comes with a Postman collection, and you can try different kind of stuff there. If you're looking for something for GraphQL specific, there's a project that is called Them Vulnerable GraphQL API. It's deployed as a Docker again, and you can see on the right side different kind of scenarios, like denial of service attacks, information disclosure, code execution, injection. So you really can go through all of them and understand what is the nature of the issue, what do you need to try out there. It's actually pretty amazing that our people created all those sandboxes that you can play around and really feel it. You can just look through the code, understand what is the root cause of the issue. You can exploit it in a safe environment and see what is the problem there. You can try the security tooling, by the way, and also see if it's effective against all those issues. So it's pretty much amazing. Another thing you can try is different kind of API security training, and probably there are a number of them out there. I know a few. So one is the API hacking exercises from Wesley. This guy's name is also XSSRed. He's helping us a lot on the webinars. And he has an amazing courses on the API security. And he also does have different kind of API hacking exercises, which is a great API security training. Also, there is a good resource which is called Contra, just I have a link here. So it's a free interactive application security training specifically on OWASP API. So you can go there and have a few exercises and have a good sense of what is this nature of every single item of the OWASP API security, which is great. I was talking before about the layers, right? API security and what we see here in terms of the security tooling. We think about the layers. So you need to have fundamental layers, which is API gateway, because on the API gateway with the API management system, you can create the access control, you can set up the encryption, you can take care about the cores, obviously you can take care about the rate limiting, caching, and authentication. So like, it's a very important thing, like, and probably a lot of you already have some kind of API gateway or API management system. Then you need to add some kind of extra protection. And a lot of people already have some WAF, or as they call it, WAAP, Web Application and API Protection nowadays. It can protect you against OWASP top 10 because they still relative to the APIs. And in many cases, WAF only provide a positive security model, but they also can help you to block different kind of malicious traffic like Tor, or block some countries, and et cetera, and et cetera. In reality, like if you're really building some robust API security program, you need advanced API security features. And what I mean by that is that it should have what we call deep API request inspection. It should be able to analyze the content for REST and GraphQL calls. It should have the API discovery and inventory features of managed and unmanaged APIs, both exposed and not exposed. It should provide protection for the OWASP API security. It should provide a protection against different kind of account takeover because it's very easy to abuse APIs, and et cetera, and et cetera. So like, we're working on that at WallArm, and we've been working on that 5 years. So like, we have customers both in the Fortune 500, but also like some amazing tech companies here out of the Silicon Valley, like Miro and et cetera. So what we do is we call it protect, discover, and respond. And it works both for APIs and apps and microservices. First of all, is discovery piece. And I mentioned this already, how to analyze all the traffic you have, and basically to give you the Swagger, or the open API specs of all the APIs you have out there, how to track changes, like what are the APIs in you, and how to find all the kind of like things that you need to care about, like ROG API, Shadow API, and etc. The next piece is protect, how to analyze all the traffic and basically protect all the applications, all the APIs, all the microservices against different kind of attacks like abuse, API was top 10, API security, bots, and etc. And also how to make sure that it's tuning free so that you don't need to tune it or create rules or play around with the different kind of regex. So it shouldn't be the way of doing that in 2022. So like, we just want you to have something that works from the minute one and can protect all of your API state from different kind of attacks. But attacks will happen, right? So like, what we also want to help you is to streamline your incident response and to provide you full visibility of what was happening, what were the nature of the attack, what were the sequences of the actions of the attacker, how to prioritize your issues, how to make sure that you have one unified workflow with all the security tooling you have, because obviously you probably have SIEM or SOAR or maybe some kind of open source tooling for that. So like, we want to automate a lot of things, help you with the smart alerts, and basically automate the verification of the attacks. So like, I don't want to talk a lot about all the capabilities here because we'll have a demo shortly. But one thing that I want to touch is the deployment options. So like, obviously when we talk about the APIs, we talk about the modern infrastructure, complicated and sophisticated environments. In many cases, it's multi-cloud, something based in the Kubernetes. You may have a lot of traffic. You may have some huge uptick in the traffic, zero kind of seasonality. So like, we try to find the way and implementing the deployment options pretty much everywhere. So like, if you have Kubernetes, you can install it as a sidecar proxy or ingress controller. If you have already some load balancer like Nginx, you can just plug in the module. If you're running in the cloud, you can find the reverse proxy in the marketplace. If you don't want to deploy anything, you can use the cloud version of the product, which we do in the partnership with the Lumen. It's the new name of the CenturyLink, which is one of the largest telecom operators. And in this case, like, you can just like route all the traffic to the cloud for analysis. I think that's a good time like to pass a word to Alex, who can talk more about the product and show the demo. Let me just stop sharing then.
Perfect. Thank you, Stefan. Let me share my screen.
It's loading. Yeah, we can see it.
Perfect. Well, thank you. Thank you, Stefan. So like Stefan said, once you, we're talking to partners on API gateways, and one of the main feedbacks we got from them is three things. When you're running API service, APIs in your infrastructure is, where are my APIs? What are those APIs? And is there something wrong with those APIs? Fair questions. These are the feedback coming from API gateways dealing with APIs every day, right? Now, what you're looking at right now is it's the console, the Wallarm console, a cloud console that allows you to manage all your API security needs from either when you start a demo with us or when you actually deployed with Wallarm, either in the cloud or your own infrastructure. What Wallarm effectively is doing is creating the API schema, the open API schema specification directly from those user connections. As your users are accessing your APIs, as your users are consuming your services, either a partner API, private APIs, or public APIs, Wallarm from those requests is able to map out and recreate the open API specification directly from those connections. You will see all the endpoints that have been discovered, the methods. In this specific example, if you're familiar to a Swagger format, you may find also this format familiar. You will see the parameters being pulled from directly from the request and the endpoints. You see a host that belongs to a header portion of the request, password in the body, and for every method that been discovered in the system. Again, there is no need to upload the schema. This is automatically being built from the user requests. Now, something important when you have a open API specification is the concept of required fields, as you can see here with an asterisk. What that means that in order to do a successful call and endpoint to a service, you must have this field and these parameters as part of the request. Wallarm is going to detect these parameters by calculating 99% presence of these parameters for every request and marking as a required field. The other thing is you're able to see also based on the name and the content, you're able to see if there is PII information, is a password being sent, is a username, a token. So it's going to mark this as a PI data. So when you think about it, this will auto-discover all your APIs. Will answer the question, what are my APIs? And also what's wrong with these APIs, or what's the content, or what are those based on the name of the endpoint. Stefan mentioned before that as you release new version of the API, you may end up with a previous version of API they should not make available anymore because you don't have any development efforts anymore. So you have a V1 here when you already have only maintaining V2. The risk of that, if you're not maintaining endpoint-specific API endpoints, you don't know if there is a vulnerability related to that API. So that could, have security concerns because you don't know about the vulnerabilities. Before even reaching out to your team, what you can do is disable this API by adding a virtual patch. And at that point, effectively, you are actually just adding the query or the path, you're able to effectively create and stop that API from any access. Then you have the time to go reach out to your development team and say to disable that at the software level. But that at this point, you removed any concern related to a potential vulnerability to that older or deprecated API. So how this is important and relevant to you is because what you see here is a source of truth of how your users are consuming your services. You as a developer, as part of your CI/CD pipeline process, you design your APIs, you give it to a client, a partner to consume your services. Those are your expectations. These are based on the open API specification. These are the expectations people, how they're going to consume your services. That may not match the reality. The reality is what you're looking right now on the screen because this is built directly from the user connections. So you're able to detect shadow APIs, deprecated endpoints that you may need to address or not. So on the right, you see your endpoints. and every specification is based on a domain. So here, what you can do is, because directly from the user connections, I can download this on the top right, the specification, Open API specification created by Wallarm from the user connections. I can go to a Swagger editor, copy paste, and actually document my APIs directly as your users are accessing your services via APIs. So this represents the real traffic and how your APIs have been used. Another use case that you have, the API that you built and you release and you provided to partners and clients to consume your services on the right. And then on the left, you will see the one actually Wallarm is generated from the user connections. What you can see is the differences from your expectations, or how you're expecting people to consume your services. On the left, the reality and the source of truth coming directly from user connections. You can see the differences in APIs and allows you to adjust and this based on the consumption of your APIs. Another important aspect of this is you can able to also see the events and attacks going to your APIs. Let me see if I have this. So you can see the events to a specific APIs and endpoints. You can see, for example, if there's an API that has been has an attack on an API endpoint with attacks. So what Wallarm is doing here is inspecting every single element of the request, from URI, header, and body. Why is this important? Because every single element of the request could be used as an attack vector. In this specific case, the payload, which is the attack, is a SQL injection in one of the fields of the API request in a REST structure found in the body of the request. The information that Wallarm is going to provide is the attack, what triggered the attack, the source IP, where this is coming from, and also the response code of the application. If you're in blocking mode, means that Wallarm protected the request from reaching out your application. Your application never had to deal with it. And also, we only allow meaningful requests going to your application. Everything else, if it's an attack, is going to be blocked by Wallarm. This will apply for any type of protocol or modern API. So if you're using GraphQL, you will see here a GraphQL body, gRPC, WebSockets. You will see, a REST and SOAP bodies as part of the request. All these are supported by Wallarm, so you can actually protect from web services and modern protocols. If you're running Kubernetes and Cloud Native, most likely you are using these protocols. As part of the protection, every request is being analyzed for all the OWASP top 10 that you can see here, from SQL injection, cross-site scripting for every request. If I expand this, you will see all the attacks incoming into the system. Something I like to show you too is the rule sets, and this is important I like to point out that one of the limitations of a WAF is the use of regexes and signature based. That is really hard to scale when you add in the complexity of requests coming from API in a GraphQL, which sometimes they can contain Python code as part of the request. So a regex and a signature based analysis is really hard to scale and provide high levels of security. And it's really complicated because you have to version the rules, you have to maintain the rules. Wallarm provides a technology which is grammar-based, a little bit like a language where you need to understand the grammar of the attack as you understand a language with a verb and pronoun, and added with a context to be able to be more precise how to identify those attacks. That, along with statistical methods, algorithms, and pieces of AI that allows you to auto-create the rule sets that at the end of the day is going to reduce the maintenance and provide a low TCO in terms of rule sets. So if you're already in blocking mode, all the attacks are being stopped at Wallarm. Your application is going to only receive meaningful requests that are important to your business. And if you have a new application you want to onboard, let's say in staging, So this application, the system still needs to learn and build the profile, the security profile for this application. So what you can do is add a rule as filtration mode, and you set it up to monitoring. And at that point, you can onboard this application in monitoring mode after you, by training the system, by clicking on false positive, by letting the system to understand and learn the security profile specific to your application. You can actually remove it and you will go back to minimal amount of rule sets. This allows you to maintain high security levels of security for your APIs with a small footprint in terms of maintenance. Something I'd like to show you related to APIs is a trigger. You may have specific endpoints that where you are doing authentication for a specific API. What you don't want is people to try to use them 30 times for the last 30 seconds, because that could be considered as a brute force attack. So what you do is you can add a reaction marked as a brute force. And as part of you can add it also to a blacklist, which for when that threshold has been exceeded, you can add the IP to a blacklist that can last for 5 minutes, 15 minutes, 30 minutes. What effectively you're doing is slowing down the request so you don't stopping brute force attack to specific authentication endpoints for your APIs. Another use case, you have a big event, you are releasing a new product and you want to see if you're under attack for that day. You have 10,000 hits per day in terms of attacks, and you want to have a notification. If that's the case, you want to send a notification to Slack, PagerDuty, or Splunk. Something I'd like to show you too is when you think about from an attacker's perspective, the first thing they're going to do is discover what you have out there, what's actually could be a potential attack vector. So by that is discovering your domain names that could be used as a target. And Wallarm is going to do the same, reusing the same concept. Is going to auto-discover all your endpoints and IP addresses using SSL information and DNS records. But the important part is how Wallarm is going to use this information. And the way it's going to use this information is in 3 different ways. Under vulnerabilities, you will see it, right? So one of the things you will see here will be, for example, it's going to run CVEs and CWEs, well-known vulnerabilities against those endpoints. And you will see, for example, the CVE number and how this can be reproduced. So by targeting all your APIs, it's going to find all these vulnerabilities that at least is well known. The other one will be a passive detection, where actually is listening to all the responses back from your application. So you don't want to be sending back database structures that should remain in your logs and not make it available to end user. It could be used against you in a SQL injection. You should not reveal your database structures. Password databases that should not be leaked to the client. And there is one more that we can go over is active threat verification. And to show you that one, you can go to our documentation site. And I describe this one in a second. The way this one works is thinking again about the attacker. Attacks will come into the system. While it's going to detect the attack, the original attack coming from the hacker, you will see the base URI, the login authentication token was used, and the payload, the malicious payload that was used. In this example, it's a SQL injection, but could be any of the OWASP top 10. Could be a cross-site scripting, could be RC, could be again a SQL injection, and also could be over any protocol. Could be gRPC over protobuf. Could be using WebSockets. Could be also complex querying in GraphQL, REST, and SOAP. The idea here is the detection of the initial attack, and Wallarm is going to take that attack and check for vulnerabilities against your system by adding between 100 to 150 variations of that attack by reusing the same URI. So you will see here the different payloads added by Walarm. And the idea here is to test your system before the hacker has a chance to do it and reveal vulnerabilities based on that. What the vulnerabilities could be log4j, could be log4shell, as you know, probably are aware of that one. So this is how Walarm is going to do the three detect vulnerabilities, using passive detection, looking for responses back, making sure there are no vulnerabilities, and active threat verification, reusing hacking intelligence to add variations for that attack and look for vulnerabilities. The other thing I want to see is the IP list, where you can actually select the list by name. So you can actually block if you cannot do business with certain countries, you can actually add it. We have already the CIDRs listed for you, where you can add an object and select by country. And you can add, for example, the regions of the country you want to block per IP block. Also per data center, if you cannot want any traffic from the Tor network, that would be one of the options you have to block these settings. So this is the main dashboard. As a security engineer, this is where I want to look for what's happening in terms of security for my APIs. In red, you will see all the attacking coming into the system, into your APIs. In blue, you will see requests, good and bad. And in the red dots, means that there is a vulnerability in your application, has been checked and has been verified, and can be potentially affect your applications. Also, you will see your applications organized based on applications. You can have your dev, your staging, and product environment. You can organize, in my case, organize on type of APIs, REST, SOAP, gRPC, etc. You can see also the incidents and hits and trends per application. We'll give you a view of top attacks going and to your APIs, and also the country code. Where are they coming from? The country code or the data center? Perfect. Thank you so much. I think we can open now to questions.
I think so too. Thanks, Alex. So guys, if you have any questions, feel free to shoot them here in the Q&A box. I see one question about the deployment. What are the ways of deployment in Kubernetes? Alex, can you cover it?
Yeah, of course. When you think about Kubernetes, is the way to deploy is a cloud native way, right? So we have multiple options to do it. We have, of course, the installation is native to Kubernetes using a Helm chart, and you can deploy multiple options. We have our ingress controller based on a Kubernetes open source, which basically has Walarm inside. So as part of the workflow, if you're familiar with Kubernetes ingress controller, that's the way you can actually use. The way you manage a Kubernetes controller, that doesn't change. The only thing difference, you will have Walarm inside protecting your APIs. You have other deployments, Istio or a more complex deployment. We also have a sidecar deployment where you can deploy as part of your application. So effectively, it's going to be another container inside that pod where your application resides, and it's going to protect all those requests inside a mesh to be able to protect your applications or your APIs at that level.
Yeah, thanks, Alex. So another question, is this a full API security scan tool, or does it work similarly to Dest? It's like, what do we call this, end-to-end API security platform? So like we have a lot of components here that are specifically tailored to the APIs. So like we have API discovery module to identify all the APIs based on the traffic. We have the active threat verification feature and testing features. It works as a Dest, but it knows what APIs to scan based on the traffic. We have this API threat prevention module, which will be sitting in line the traffic and provide the real-time attack detection and mitigation. So like it's all over the place. It's a full platform to protect your APIs and microservices. Is there any noticeable performance impact when you're inspecting the request? Do you need a host agent for Docker? So this is another question. So we actually put a lot of efforts during the last years to make sure that there is a almost near zero latency added. Obviously, there would be a few milliseconds added. Like we still need to parse the request. We still need to apply the attack detection techniques to every parameter, but we made it super fast. It's developed in pure C. So that's why like some of the most loaded websites in the world are protected with a wall arm. And obviously all those companies run their performance testing before it goes to production. So like feel free to try it out. We're pretty confident it will be within your requirements for sure.
Yeah, let me add something else too. So in terms of architecture, the node works in memory as an asynchronous analysis as part of the request flow. So the analysis happens asynchronously as part of your request flow, all in memory. Also, we provide metrics to be able to calculate that latency. We have two metrics available. One is the monotonic clock, which actually is from a user perspective, the time the request takes to be processed. And the other one is the user clock that actually will count with evictions when the CPU is actually evicting the process because he needs to give room for another one. So those metrics will be essential for you when sizing deployments as a sidecar container or Kubernetes. So we not only have like Stefan mentioned, we put a lot of effort, but also we have the metric that allows you to measure and maintain the SLAs you need.
Yeah, thanks, Alex. What can you do against the API abuse? So I think this is the last question that we can cover. Alex, can you cover it?
Yeah, so one of the things we were able to do, depending on API abuse, is one of the ones I described during my demo, which is a brute force attack, where you effectively rate limiting by adding IPs to a blacklist to stop further consumption of those services depending on a certain threshold. The other one would be also a credential stuffing as part of that API abuse. Those two features are available, and they're all resources useful when it comes to API abuse.
Yeah, thank you, Alex. And I think we don't have any more time, unfortunately.
Well, Alex and Stepan, thank you both so much for joining us today and walking us through everything. I'd like to quickly remind our audience that the session was recorded. So following this, you'll receive an email with a link to access the recording on demand. You can also find it living on the Security Boulevard website at securityboulevard.com/webinars, and be sure to look in the on-demand section. So we do have those 4 $25 Amazon gift cards to give out. Our first winner is Jose A. Our second winner is Jeannie H. Our third winner is Sahir S. And our fourth and final winner is Angela B. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. But if you don't see that email, be sure to keep an eye on your spam folder. I would like to thank WallArm for sponsoring today's webinar. And I would also like to thank you, our audience. We really appreciate you spending time with us today. Please take an extra moment to fill out our brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we hope to see you at an upcoming Techstrong Learning webinar or workshop. Everyone, have a great rest of your day. And Stepan and Alex, again, thank you so much.
Thank you.
Thank you, everyone.